All right, so the next example deals with using a standard deck of playing cards. So remember, in a standard deck of playing cards, there are 52 cards. And so this will be part two of the theoretical probability for this lesson. So make sure you go back to part one. There were some examples that we did in part one. And then this is the second example, and that will be part two. All right, so remember that in a standard deck of playing cards, you have 52 cards, and there are 4 suits. You have clubs, hearts, spades, and diamonds. And in each suit, there are 13 cards. You have ace, and then the card number 2, a card number 3, a card number 4, all the way to 10. And then you have jack, queen, and king. Okay, so notice that in each suit there are 13 cards, there are 4 suits, and so you get 52 cards. All right, okay, and notice that the face cards, these are your face cards right here. So the face cards are jack, queen, and king. All right, so those are your face cards. All right, that's what they mean by face cards. Okay, so using the standard deck. Okay, so our next example is on the standard deck of playing cards. Okay, so let's find the probability. Find the probability. Okay, A. Okay, so find the probability of being dealt. Let's say a jack. All right, a jack. All right, so if you look at this, so this is your sample space. Remember in the previous lesson we talked about sample space? And so the sample space contains 52 cards. All right, so you have 52 cards, and each of those cards are equally likely of being picked. Okay? So each card, I want you to notice this, so each card has the same chance of being picked as every other card. Okay, so that's going to be theoretical probability. There's no experiment being done. You're just in a standard deck of 52 cards. If there's no cheating or anything going on, what's the probability you're going to pick, let's say, this one, or this one, or this one? All right, so each one has the same probability. Each outcome is the same. Okay? All right. So the event is that you're picking a jack. So in our case, though, you got to remember, in this sample space, how many jacks are there? There's 1, 2, 3, 4, right? Out of what? 52. So remember, when we talked about the definition of theoretical probability, so that's the number of outcomes in the event. So our event is picking a jack, and there are 4 of them, divided by the total number of possible outcomes. So how many possible outcomes are there? There are 52. Okay? So the probability of jack, picking a jack, is going to equal 4 divided by 52, which reduced, it will be 1/13. Okay? So 1 divided by 13. All right, letter B. Suppose you want to pick a, let's say, a heart. A card that's a heart. All right, well, let's look at that. So my event now is I want to pick a heart. So here are my hearts right here, right? So that's that suit. How many hearts are there? There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Remember, we knew that there were 13 cards per suit. Okay, so the probability of being dealt a heart is going to equal 13 divided by 52. 13 divided by 52, which reduced is 1/4. Okay, 1/4. Okay, so out of every 4 cards, one of them is a heart. So 4 cards, and one of them is a heart. So the probability of picking a heart is 13 out of 52, which reduces to 1/4. So there's a 25% chance of being dealt a heart. Kind of makes sense because doesn't that look like 1 out of 4 suits? Remember, heart's one of the suits, right? How many suits are there? 4. So 1 divided by 4 is what this is. Okay? All right, C, what's the probability of picking a picture card? A picture card. All right, well, so in this case, let's call this picture card a face card. Okay, so that'll be called a face card. All right, so meaning a jack, queen, or king. Okay, that's our picture card. So when you hear the word picture card, they mean face card. So the probability of getting a face card, of being dealt a face card, will be, well, how many faces are there? There's 3 here times 4 is 12, right? So that's 12 divided by 52. All right, now let's go ahead and reduce this. 12 divided by 52. So when I look at 12 divided by 52, let's see. So they're both divisible by 4, right? So 12 divided by 52 will be 3 divided by 13 when you reduce it. Okay, 3 divided by 13. So 12 divided by 4 is 3. 52 divided by 4 is 13. All right, so D. Let's look at a card, being dealt a card that's greater than 4 and less than, let's say, 8. So greater than 4 and less than 8. Now be careful, don't, greater than 4 means 5 or bigger. Okay, it doesn't say greater than or equal to. Okay, so that's important. So what I'm interested in, so remember my event here will be 5, getting a card, being dealt a card that's 5. What else? 6, 7, and that's it, right? Because it says less than 8. Does it say less than or equal? No, it says less than. So less than 8 means this. Greater than 4 means 5, 6, and so on. So this event here, a card greater than 4 and less than 8, it helps you if you actually listed your event. And so the elements in that event, the outcomes in that event would be 5, 6, and 7. And so what I do now is, if I want to find the probability, and I'm going to call this probability of E since I have E listed here. So the probability of this event right here being dealt a 5, 6, or 7, I have to count how many 5, 6, and 7s I have. So 5, 6, 7, so that's 5, 6, 7 of clubs, 5, 6, 7 of spades, 5, 6, 7 of hearts, 5, 6, 7 of diamonds. So that's 3 times 4, which is 12. So there are 12 of those, y'all agree? Because there's 5 hearts, 5 clubs, 5 spades, 5 diamonds, and so on with the 6 and so on with the 7. So it's going to be 12 divided by 52, which is 3 divided by 13. Okay? E, suppose I want to find the probability of being dealt a card. So let's see, being dealt the Queen of Spades, the Queen of Hearts. Queen of Hearts. Well, let's look at that. So probability of Queen of Hearts. Well, how many are there in this? How many Queen of Hearts are there? Well, there's just this one, right? So that's 1 out of how many? 52, because there's 52 possible outcomes. Okay, F. Suppose you want to find the probability of being dealt a card with a blue heart. A card with a blue heart. Being dealt a card with a blue heart. Well, if you look at that, your colors, let's look at your colors. So there are only 2 colors here, black or red. And so your clubs and spades are black, your heart and diamonds are red. So if I pick a card, will any of these be blue? No, right? So none of those is blue. So there's no blue hearts at all. They're all red. So so is this event possible? So the question is this event possible? No, that event's not possible. There's no way I will ever be able to be dealt a blue heart. So the probability of blue heart is 0. It's an impossible event. This is impossible. That event is impossible. Okay? What about G? Probability of being dealt a spade and at the same time a heart. Being dealt a spade and a heart. All right, guys, let's think about this. You see the word "and," right? How many cards are you being dealt? You're being dealt one card. One card. What's the probability that that card's going to be a spade and a heart? A spade and a heart. For any of these cards, both a spade and a heart. Here's a spade. Do you see a heart there? Here's a spade. Do you see a heart there? Here's a heart. Do you see a spade? Here's a heart. Do you see a spade? No. So is this, again, is this event possible? Is this event possible? No, it's not possible. Okay, no. So what's the probability of a spade, of being dealt a spade and a heart? It is 0 also. Okay, now what if you had this? What if you had H? I'm going to have to do H on the next page. What if you had H? What if it said a spade or a heart? A spade or a heart. H-E-A-R-T. A spade or a heart. That's similar to what we did. You remember that word "or" in the previous part 1, that other lesson? So a spade or a heart means either I want a spade or I want a heart. So that is possible. So how many spades are there? There are 13. How many hearts are there? There are 13. So the probability of a spade or heart, so there's 12 here, 13 here, 13 here, right? So it's a probability of getting a spade or a heart. It didn't say and. If it said and, there's no way a card can have both spade and a heart. But if you pick a card, can it be a spade or a heart? Sure it can. The word "or." That's the thing you got to look at. There's the word "or." So that's going to be 26 divided by, how many cards are there altogether? 52, which is 1/2. Kind of makes sense that's a half because spade and hearts takes up half of this, doesn't it? Okay, so that's going to take care of this problem. So I just wanted to do a problem with a standard card deck because that's the most common theoretical probability example that's always used. So the standard deck is always the most common one used when we talk about theoretical probability. Okay? All right, so that's going to take care of this lesson.